am Shahtaj, Assistant Professor working in the Department of Computer Applications in Crescent Institute of Science and Technology. Today I am going to talk about CPU scheduling algorithm in operating systems. The outline is basic concepts, scheduling criteria and scheduling algorithms. There are 4 types of scheduling algorithms. Let's see one by one. Before going into scheduling algorithms, you must know about these terms: multiprogramming, job, user, process, CPU, IO burst cycle, and preemptive scheduling. Let me explain it one by one. Multiprogramming means a number of programs can be in a memory at the same time, and it allows overlapping of CPU and IO time. And next comes to the job. Jobs are programs that runs without user interaction, and obviously you know about users. Those are user interactions. Next comes the process. Process is the common name for both CPU and IO burst cycle. CPU and IO burst cycle characterizes process execution which alternates between CPU and IO activities. CPU times are generally much shorter than IO times. Preemptive scheduling is an interrupt causes the current running process to give up the CPU and be replaced by another process. Now we are going to see about the schedulers, which is used to select the process in the memory that are ready to execute and allocates the CPU to one of them. CPU scheduling decisions may take place when a process switches from a running to a waiting state. Next thing is switches from a running to a ready state. Next is switches from waiting state to ready state, and then is terminate state. Among this, 1 and 4th comes under non-primitive scheduling, and other than 1 and 4 comes under primitive scheduling. Criteria for performance evaluation, and there are certain words like devices, systems, request, job, which they are going to be used in previous slides. Then utilization, throughput, service time, queuing time, residence time, response time, and think time. I'll explain you one by one. Utilization is the fraction of time a device is in use. Throughput is a time of job completion in a period of time. Service time is a time required by a device to handle the request. And next comes the queuing time. It is also a time on which queue is waiting for a service from the device. Residence time, the time spent by the request at a device, and it also has a formula: residence time equal to service time plus queuing time. Next comes the response time. It is a time used by the system to respond to a user or a job. Next comes the think time. It is a time spent by the user of an interaction system to figure out the next request. The goal is to optimize both the average and the amount of variations. Next, I'll explain you the 4 types of scheduling algorithms one by one. First is first come first serve algorithm. It is also called as first in first out algorithm. From the name itself, you can know what does the algorithm says. Whichever the process comes first, it will be served first. In the sense, it will be taken by the CPU first to complete its process. Here I will explain you the first come first serve algorithm with a Gantt chart. I have taken 4 processes, which is P1, P2, P3 and P4, and the appropriate arrival time for the processes 0, 1, 2, 3. Process 1 starts from 0, and I have also given the service time, which is 8, 4, 9 and 5. P1 process starts from 0 time and it completes its job by 8 service time, and the P2 starts at the time of 8 and then it completes its job by 12, and P3 starts by 12 and completes its job by 21. P4 starts by 22 and it completes its time by 26, and from this we can calculate the average wait time for each of the process. First process has been waiting 8 service times to complete its job. So 8 minus 0 plus Next process P2 complete its time by 12, and before that one process has been completed. So 12 minus 1 plus third process is completes by 21, and before third process 2 process has been finished, so minus 2 plus fourth process completes by 26, and before that it has completed 3 process, so 26 minus 3 divided by total number of processes 4, so 61 divided by 4 is equal to 15.25. Next comes the shortest job first scheduling algorithm. From the name itself you can find CPU is ready to select the process which has the very shortest service time. It will first select the shortest service time to complete its job first. Here there is a formula: T of n plus 1 is equal to W star T of n plus 1 minus W star T of n. I'll explain the terms one by one. T of n plus 1 is the time of next burst. Next comes the T of n. T of n is the time of current burst. Capital T of n is the average of all previous bursts. W is the weighting factor emphasizing the current or the previous burst. Now we will see about primitive shortest job first algorithm with an example. I have taken 4 processes and respective arrival times and the service times. P1, P2, P3, P4 are the 4 process, and the arrival time is 0, 1, 2, 3, and the service time is 8, 4, 9, 5. And now we will have a confusion which process has to come first. So now we are going to take the minimum arrival time as the first process, and now looking at the arrival time, 0 is the minimum arrival time which is held by the process P1. So we have selecting P1 as the first process. To select the next process, we are going to look at the service time. Minimum service time is 4, which is held by the process P2. So we are selecting the P2 as the next process to P1. Next comes the P4 process because it has the next minimum service time. Next I am choosing the process P1 because it has the next minimum service time. Next comes the P3 which has the maximum minimum time, so it is given in the last. Accordingly, we have to select the jobs. Now let me explain you about the priority based scheduling. For example, assign each process a priority. Schedule highest priority first, and notice that all processes within the priority are FC and FS. FC and FS are nothing but first come and first serve. Priority may be determined by user or by some default mechanisms. The system may determine the priority based on memory requirements, time limits, and other resource usage. In priority based scheduling, we will first have a column called priority levels. There, before drawing a Gantt chart, we will first note down the priorities of each process. Based on the priority levels of each process, we will assign the first priority to the respective process. In this way only the priority based scheduling runs. Next comes the round robin scheduling algorithm. In round robin, there is a term called quantum number. Based on the quantum number, we will decide the Gantt chart. Quantum number is nothing but each process runs at a particular time as specified in the quantum number. For example, if a process P1 should run for 4 minutes, then the quantum number of process P1 is assigned as 4. Let me explain you the Gantt chart with an example. P1 starts from 0 arrival time and it will run up to 4 service time. The rest of the 4 service time will be executed later. Next, CPU is carried with the process 2. It has the service time of 4, so all the 4 service time will be completed within the same quantum. So P2 completes its whole process in the same cycle. Next comes the P3. It has the service time of 9. So here now quantum number is 4, so it will complete 4 service time and the rest of the 5 service time will be executed later. Next comes the process P4. It has a service time of 5. 4 service time will be executed in the first cycle and the rest of the 1 will be executed in the second cycle. All the 4 process has been executed in the first cycle. Next it is coming to the second cycle. P1 has left 4 process, so it will take over that 4 process and complete its job fully here. Next comes the P2. P2 has been already completed its process in the first cycle, so it will not enter into the second cycle. Next P3 is taking the CPU time now. It will complete its 4 quantum here and it will resume 1 service time in the later cycle. Next comes the P4. P4 has left only 1 service time. It will complete it in the second cycle. And again after P4 is completed, again P3 will take the CPU time to complete its left out process. 1 process has been left out for P3 to complete its full job. So final cycle will be taken by P3 to complete its job. Here I have explained the round robin scheduling algorithm. Now these are the topics we have covered today. So thank you. We will meet in next lecture.